Today, lesson 32C, multiplication and power to power exponents. Yesterday we started with the idea of exponents. We took off from what you learned in the 6th grade. We continue with this idea of simplifying and evaluating and writing it as extended products and all of those ideas that we talked about yesterday. So let's go ahead and get started. Yesterday we talked about if we are multiplying things with the same base, we list the items out by extended products, where 4 to the third is 4 times 4 times 4, and 4 to the second is 4 times 4. And we can clearly see we have 5 4s altogether, so that simplifies in exponential form as 4 to the 5th power. Or we did this one yesterday. Same idea, extend the product or expand the product, and we can see we have in exponential form 2 to the 7th power. And then one of the things we talked about yesterday was this. Trying to figure out whether the product was positive or negative. So number one, positive or negative? Good, because if we extend the product, we have a negative times a negative. Be a little more careful on this one. Positive or negative?
Positive.
Really? You sure?
Yes.
Why? Today is more about why than anything else. Why? Yep. All right, good. The negative 6 to the 3rd power, that's negative 216, and then negative, or the opposite of that, as you said, that would be a positive. So yes, that is positive. All right, I'll give you about 10 seconds to do number 3 and number 4. All right, number 4 clearly is 3. That's one of the big ideas from yesterday. The opposite of 7 squared is negative 49, so that is negative. And then number 4, similar to number 2, but you have to pay attention to what is happening right here. That is positive 16, and the opposite of positive 16 is negative 16, so that product would be negative. Okay? All right, so today, first thing we're going to do is we're going to extend on the ideas that we talked about yesterday. So multiplying with different bases. So if we have 3 squared times 4 squared times 3 cubed times 4 to the 5th, one way of thinking about this would be, first of all, rearranging, grouping together items with the same bases. And to do that, we're using the commutative property, because we have straight multiplication. Now, if I extend the product on the 3's, I can see that I have 5 3's altogether, from 3 squared times 3 to the 3rd. And then if I extend or expand out the 4's, I have 7 4's. And so that would simplify to 3 to the 4th power times 4 to the 7th power. Same idea in the next example. If I have this, I can group my 2's together using the commutative property, extend the product, and I can see that I have 5 2's and 5 5's. That would simplify in exponential form to 2 to the 5th times 5 to the 5th. As you are finishing up 5 through 8, one of the standard rules is we should keep our bases in numerical order. So listen to what I just said. We should keep our bases in numerical order. So for a problem like this one, we should really have 2 to whatever power first times 3 to whatever power second. And that's really just a lead into how we extend this out next year. Next year we extend this out with variables. And the typical rule for variables is variables should be in alphabetical order. So same thing when the base is a number. Numerical order. All right, let's take a look at 5 through 8. 5 through 8, extending the product after using the commutative property looks like this. I can see that I have 7 2's and 6 3's. Therefore, in exponential form, we have 2 to the 7th times 3 to the 6th. The number 6, the first thing I'm going to do is use the commutative property to group like bases together. Extend the product. I can see that I have 5 6's and 6 8's. Therefore, it should be 6 to the 5th times 8 to the 6th. Notice in both of these, once again, I have the bases in order numerically. I have 6 as a base before 8. I have 2 as a base before 3. Let's make sure that we are writing these things correctly. Number 7, using the commutative property, and then extending the product. I can see that I have 7 5s and 5 negative 7s. In numerical order, we should have 5 to the 7th times negative 7 to the 5th. Notice that I do have parentheses around the negative 7. Typically, if I see parentheses around a negative base here, I retain it there. And then number 8. Commutative property, extend the product. I can see that I have 6 negative 3s and 6 4s. Therefore, in exponential form, we have negative 3 to the 6th power with parentheses around the negative 3 times 4 to the 6th. All right, let's go to the back side of the notes. Now, power to a power, 5 cubed squared. We're going to deal with this 2 different ways. One way would be thinking about it like this. 5 to the 3rd power is 5 times 5 times 5. We're extending that product. But I have 2 groups of those 5 times 5 times 5s, and so I will multiply those together. 2 groups of those 5 times 5 times 5, and I can see now that I have 6 5s, so therefore, in exponential form, it is 5 to the 6th power. Now, that's not the only way that I could have done that. I could have done it this way instead. I could have written out thinking about the outside exponent first. So if I did that, I would have 2 groups of the 5 to the 3rd powers. 2 of them. And then if I extend the product there, you can clearly see I have the same thing. So it doesn't matter how you think about this. We're going to end up with 5 to the 6th power both ways. Okay? All right, can I get all of you to do 9 through 11? Number 9, we have 3 squared to the 4th. So I have 4 groups of the 3 to the 2nd powers. If I then extend the product again, I can see that I have 2, 4, 6, 8 of those 3s. The one thing that I think some of you didn't see, the instructions have changed here. It says write in exponential form and evaluate. So I'm going to go ahead and give you the answer to number 9, but then I'm going to give you another minute to figure out what 10 and 11 should be. This is 3 to the 8th power in exponential form, but it is 6,561. Now, let me just talk about this really quickly. If I'm asked to evaluate this, I do not do this. I do not go 3 times 3 is 9, times 3 is 27, times 3 is 81, times 3 is 243, and keep doing that. I would never do that. I would do it using the extended product right here. This is 9. This is 9. This is 9. That's 9. 9 times 9 is 81. And so I have 81, sorry for the sloppy writing there, but I have 81 times 81. So I'm only really doing one multiplication to figure out that 3 to the 8th power is 6,561. Just going right to left means you're not thinking about all the times we've talked about the distributive property. Not the distributive property, the commutative property. All right, I want you to now take whatever you got from 10 and 11 and evaluate, because the instructions do say to evaluate. Number 10, extending the products. We can see that we have 7 to the 4th power, and then evaluating that, we get 2,401. I, of course, would say this is 49, and that's 49, and 49 times 49 is 2,401. Number 11, we have this, extending the product, and then extending it again. I have 9 of the negative 2s, and that is negative 512. Lots of ways you could do that. Once again, I would group this together in groups of 3. We have negative 8 times negative 8, which is 64, times negative 8 is negative 512. Question. Because I noticed this when I was walking around. Some people have this in exponential form instead. Is that okay?
No.
Why not? this is all about, and this is one of the themes all year, is about equivalency. You know, sometimes we have things that represent the same value, and it's okay to write it like that, and sometimes it's not. For example, typically, 2/4 is equivalent to 1/2, right? But we want to see 1/2 over 2/4. I mean, yes, 1/2 over 2/4. So the question here is this. Is this okay? Tell me, yes or no? No. Okay, I'm still hearing yeses and nos. Will the answer to this be negative 512? Sure it will. So in this case, it is okay. And it's only because the exponent is odd. Okay, and that's one of the things we talked about yesterday. Probably better to write it with parentheses around the base, but it doesn't matter. You'll get the same thing. All right, so now let's put both ideas together, where we have 2 bases and power to a power. Well, it's the same idea. So if I have 2 to the 3rd times 3 to the 4th, all of that to the 2nd, I could write down 2 groups of them. Then, like some of the previous problems, I'll group like bases together. So I'll group my 2's together, or things with 2 as a base together, and things with 3 as a base together. And then if I extended the products again, I can see that I have 2 to the 6th power times 3 to the 8th power in exponential form. Remember, we like to see bases in numerical order. So let's finish up this lesson by having you quickly do 12 through 14. In 12 through 14, do you have to evaluate?
No.
No. So it's okay to leave it in exponential form. Mika, hold on a second. There we go. What'd you get?
3 to the 8th power times 4 to the 8th power.
Very good. 3 to the 8th times 4 to the 8th. Here's the reason why. Extending the product, using the commutative property. Extending the product again, we have 8 3's and 8 4's. Therefore, it is 3 to the 8th times 4 to the 8th. Alexia, number 13.
2 to the 15th power times 8 to the 9th.
Very good. Extending the product, using the commutative property. Extending the product again. I have a lot of 2's, 15 of them, and 9 8's, and therefore it is 2 to the 15th times 8 to the 9th. Let's go with number 14. AJ.
Negative 7 to the 4th in parentheses are negative 7 times 8 and 6.
Okay, and I was waiting to see if you were going to put parentheses around the negative 7 as a base. And so let me go ahead and do this the same way I've done all the other ones. And the reason why I'm bringing it up is in 3rd period, somebody said this. They said this. So we've already come across a problem where it did not matter whether the parentheses were around the base or not. Does it matter in this one? Yes, it does, because this gives us a negative answer. This gives us a positive answer for that part. So it does make a difference. So you cannot do this for this one. Okay? All right. We are finished with this lesson.